Okay, next problem. The crank and the connecting rod of a vertical petrol engine running at 1800 rpm or 60 mm and 270 mm respectively. Diameter of the piston is 100 mm. Mass of the reciprocating parts 1.2 kg. During the expansion stroke, when the crank has turned through an angle of 20 degree from the top dead center, gas pressure is 650 kN per meter square. So what do you understand from the question? Only one pressure is given. It is single acting cylinder. Mass of the reciprocating parts is given. Theta is directly given. All the required data are directly given to you. No hidden questions. Okay. Net force on the piston. Okay. Net load on the gudgeon pin. Thrust on the cylinder wall. Speed at which the gudgeon pin load is reversed in direction. So this fourth question only is a tricky question. All other things are very easy for you. Write on the given. This is the diagram for the given. It is a vertical engine. Keep in mind, it is directly mentioned in the question. Vertical petrol engine. Only if nothing is mentioned, it is horizontal. Okay. Or if they are giving a vertical engine diagram, it is vertical. Normally in exams, you will not get the diagram for the questions. Okay. So if you look into the diagram, you will get all the required data. Read the question carefully. Now let us list down the given data. 1800 rpm n, omega is 2 pi n by 60, 188.52. So R is 0.06 meter. Length of the connecting rod is 0.27 meter. Bore diameter is 0.1 meter. Mass of the reciprocating parts 1.2 kilogram. Gas pressure is 650 kilonewton. So don't forget that 10 power 3 in the kilonewton. So I have not written it here. In notebook, when you are writing, you have to write 650 into 10 power 3 Newton per meter square. Kilonewton, if you write, you will miss the 10 power 3 in your calculation. Please write 650 into 10 power 3. Theta is 20 degree. Okay. So what are all the results I am going to find? Net force on the piston, Fp. Net load on the gudgeon pin, Fq. See here. In this problem, I am writing it as Fq. Whichever is suitable from the given results, you take that. So this force on the gudgeon pin could be Fp or Fq, depending on the question you can choose. If they are asked Fq, gudgeon pin load is asked, and also Fq is thrust on the connecting rod is asked, then gudgeon pin load is Fp. If they specifically ask piston force and load on the gudgeon pin, then load on the gudgeon pin is Fq. You decide between the two. Both are considered to be approximately correct. Okay. So next is your thrust on the cylinder walls. Thrust on the cylinder walls is Fn. Speed at which the gudgeon pin load is reversed, omega n. Okay. So let's move on. I'll start doing a prerequisite data. Obliquity ratio L by R. So L is 0.27, R is 0.06, 4.5 is n. So phi also I need to find out. Theta is given to be 20 degree. So sin 20 by 4.5, which is 0.076. Sin phi is 0.076. So solve for a sin inverse. Phi is comes around 4.36 degree. Okay. Next, net load on the piston. This is a FP formula. Since it is a vertical engine, we are going to get this third component in the formula. And whether I should put plus or minus here. So my theta is 20 degree. Therefore, my piston is going to travel downwards. Piston travel downwards from 0 to 180 degree. Okay. So your weight is going to help you in this case. Gravity is going to help you. Therefore, you should choose a plus sign here. If your theta is 180 to 360, then your piston is going to travel upwards. There you should choose a minus sign for W. Okay. Now let us find out pressure into area. Net load on the piston is pressure into area. Pressure is 650 into 10 power 3. Area is 0.1 meter. It's the diameter of my cylinder. Okay. Therefore, pi by 4 d square 0.007854. Okay. So FL equal to 650 into 10 power 3 into area 0.007854, which comes around 5105 Newton load on the piston. Okay. Next is my inertia. Load on the piston is 5105 Newton. Next is inertia, mass into acceleration. MR omega square R cos theta plus cos theta by n. Okay, so mass of the reciprocating parts is 1.2 kilogram. Omega is 188.52. R is 0.06. Theta is 20. N is 4.5. Substitute everything into the formula. Okay, so mass of the reciprocating parts is 1.2 kilogram. Omega is 188.52. R is 0.06. Theta is 20 degree. Okay, so 2 theta is 2 into 20 degree, 40 degree. Okay, N is 4.5. So if you solve this, you will get 2840 Newton. 2840 Newton is the inertia force. So these things you have to try with your calculator. Since time is not there, I am going to directly give the answer. Please solve it. This PPT will be shared to you. Cross check your answers. Summa, you just don't copy down. It is not useful. Okay. So weight of the third component of the formula, weight of the reciprocating parts, mass into gravity, 1.2 into g. Okay. 9.81. W1 1.2 into 9.81, 11.772 Newton. Okay, so now let us solve for piston effort, net load on the piston, the first question, right? So that is FL, a default minus symbol, inertia force Fi, plus weight of the reciprocating parts because theta is 20 degree, piston is moving down. So therefore I am going to take a plus here. Okay, where? Here. A default plus here because of theta equal to 20 degree, which means piston is moving down, gravity is helping you, therefore plus. Here keep the default minus symbol and include the symbol of inertia force answer inside bracket. Okay. So FL is 5105, inertia force 2840 plus symbol, weight of the reciprocating part 11.772. So substitute everything 5105 minus 2840 plus 11.772. The answer is 2276.8 Newton. 2276 Newton is the answer for piston effort. Okay. We got 5 more minutes. Piston effort is 2276. So net load on the gudgeon pin or thrust in the connecting rod. So in this case, I'm going to, since I have already found out FP, now I want to find out gudgeon pin load. So gudgeon pin load here is FQ. So you can choose between the two depending on the question. Okay. So here I'm going to find out FQ for net load on the gudgeon pin. What is the formula for FQ? FP by cos phi. You know FP and phi. FP is known 2276. Just now you have found out. Value of phi is 4.36 degree. You already found out. Just put it in the formula. 2276 divided by cos 4.36 degree. So it comes around 2283.4 Newton. Okay. If you see here also FP and FQ are almost equal. Okay. 2283.4 Newton. So that is the net load on the gudgeon pin or thrust in the connecting rod. 2283.4 Newton. So next subdivision of the problem, thrust on the cylinder wall is Fn, Fp tan phi. Here also everything is directly available. Fp is 2276, phi is 4.36. Substitute the numbers 2276.8 into tan phi, tan 4.36. It is 173.5 Newton. Direct formula substitution. Now it's very simple. Okay. So fourth part is the tricky part of the problem. Speed at which the gudgeon pin load is reversed. Okay. Here again I am going to solve. Similarly, I am going to solve for omega. Speed at which the gudgeon pin load is reversed. Here, if you look carefully, when the speed is getting reversed, it means that the FP will become 0 and then it will become negative. Reversal means the vector having some particular magnitude in a direction slowly becomes 0 and then gets extended in the negative direction. That 0 point I am going to find out. Okay. FP. Put FP equal to 0 in this formula and keep omega as omega 1. Solve for omega, what we have done in the earlier problem. Okay. So load reversal takes place when piston effort reaches 0 and begins to change direction. Then it will become negative after that speed. Okay. So that speed I am going to find out. This could be found out by equating the above formula of FP to 0 and finding the value of velocity, angular velocity. Okay. So put 0 equal to FL minus Fi plus WR. How much time we have? 2-3 minutes more. We'll complete this problem. 0 equal to FL minus Fi plus WR. Okay. FL is 5105. Phi is going to have the omega, so don't put Fi value directly. 11.8. So 0 equal to, only for this formula which contains the omega, substitute the formula itself straight away. I am going to write the inertia formula. And in that, except omega, I am going to write all the other values directly and solve for omega. Okay. So 5105 is FL. This entire thing is Fi. In that, I am going to replace omega with omega 1 and solve for omega 1. And weight of the, this just write this formula. I'll put all the numbers. This allows you to expand and write again the formula again and expand and put all the values into the formula except your omega 1. In place of omega, I'm going to write omega 1 and solve for it. Okay. So 5116.8. So what I have did, I have just added this 11.8 to the previous term. I'm going to, these two are plus, right? So add it to this. Just add this number 5116.8 minus of this. So solve for omega. Okay. Omega equal to 5116.8. You have to do slowly, do it mathematically. Don't urge it. Okay, slowly do it. It's a very simple step. Just do the numbers, solve for the cos theta inside the bracket and do LCM, add it, multiply it outside. Then if you finally find it out, it is 253.04 radians per second. Convert it into RPM. Okay. I think it is not required. In this question, it is not as this angular velocity at the question. If the question reads angular velocity, then you can leave it as omega. Okay. Anyway, for safety, find n also. Just reverse it. 2 pi n by 60 equal to 253. Find n. So it comes around 2416.3 RPM. So these are the results. I'll sum up the results. Piston effort FP 2276. Net load on the piston, don't forget the units. Write it carefully. FQ is 2283.4 Newton. Thrust on the cylinder wall FN 173.5 Newton. The speed at which the gudgeon pin load reverses N1 equal to 2416.3, or you also write omega here. Okay, omega 1 equal to 253.0. So that is the end of this problem. So this is taken from your Rattan textbook example problem 30.